Let's solve another example, but let's make it more interesting. Suppose the question says, solve the initial value problem. Solve the second derivative of y minus 6y prime plus 9y equals to t squared e to power 3t. Y at 0 is equal to 2 and y prime at 0 is equal to 17. So as we know, the Laplace of the second derivative of y minus 6 times the Laplace of y prime plus 9, the Laplace of y is equal to, well, here you have the Laplace of, well, t squared e to power 3t or e to power 3t times t squared. The order is not important, but since if you want to check the first translation theorem, maybe writing it this way can help you to identify e to power at. So very well. So for this guy, we already know this equals to s squared f of s minus s f of 0 minus f prime of 0. And for Laplace of y prime, we have negative 6. Let's put this in parentheses, s f of s minus f of 0 plus 9 f of s equals to, so first of all, we know that the Laplace of t to the second is equal to, well, here you have 2 factorial, which is just 2, divided by s to the third, but here you have a, which is 3, so we get s minus 3 to the third. So again, recall that the Laplace of t squared is 2 factorial divided by s cubed. First translation theorem says it's going to be 2 divided by 2 factorial, just 2 divided by s minus 3 to the third. Okay, so far so good. Y at 0 is equal to 2, so this is just 2, this is 2, and y prime at 0 is 17. Okay, we have s squared f of s minus 2s minus 17 minus 6s f of s plus 6 times 2, which is just 12, plus 9f of s equals to 2 divided by s minus 3 to the third. The rest is just pure algebra. So if you factor out f of s, it becomes s squared minus 6s plus 9. And here you have negative 2s. And here you have 12 minus 17 minus 5 equals to 2 divided by s minus 3 to the third. Very well. Let's bring these two terms to the right-hand side. So f of s times s squared minus 6x plus 6s plus 9 is 2 over s minus 3 cubed plus 2s plus 5. Well, f of s becomes 2 divided by, here you have s minus 3 to the second times s minus 3 to the third plus 2s plus 5 divided by s minus 3 to the second. Very well. So as you can see, we're going to combine these two fractions. F of s becomes 2 plus 2s plus 5 times s minus 3 to the third divided by s minus 3 to the fifth. Pure algebra. Very well. So we need to decompose this and try to figure out what are the partial fractions that we are dealing with. Very good. So let me erase this part of the board. I need more space. So my f of s is so far 2 plus 2s plus 5. And here you have s squared. Actually, here you have s squared. And you have minus 6s plus 9 times s minus 3. And can we factor out anything? We don't have anything to factor out. So we're going to eventually multiply all of these together. Very good. So let's see, what do we get? We get 2 plus s squared minus 6s plus 6s plus 9. And then here, if I multiply these two, I get 2s squared minus 6s. And here you have 5s minus 15. Then you have to do another multiplication. So we get minus s minus 15 divided by s minus 3 to the 5th. So f of s becomes, it's a very long fraction, 2 plus. So if you multiply these term by terms, you get s to the 4th. And here actually 2s to the 4th. So we get 2 plus 2s to the 4th minus s to the 3rd minus 15s. Now let us just multiply these. Minus 12s cubed plus 6s squared plus 90. And now you just distribute 9 into parentheses. Plus 18s squared minus 9s minus 135 divided by, well, s minus 3 to the 5th. Ooh, now you need to combine like terms on the numerator, which is, let us look for s to the 3rd first. So we get negative, you have 2s to the 4th minus 13s cubed. And here you have 24s squared. And here you have, let me see, negative 15s minus 9s, negative 24s. And then we have 90, and here you have 133. You get negative 43 divided by s minus 3 to the 5th. So our goal is to write this in partial fraction form. But because of the repetition on the denominator, we're going to have the following. This guy becomes, let's see, what do we have? This guy becomes f of s equals to a divided by s minus 3 plus b divided by s minus 3 squared plus c divided by s minus 3 to the 3rd plus d divided by s minus 3 to the 4th plus e divided by s minus 3 to the 5th. So because of repetition, we're going to list these all and then take the common denominator between these and set them equal to this numerator. Very long process. So let us do that. So if you start multiplying these, then what do we get? We get 2 divided by s minus 3. So by doing that, a becomes 2. Well, in this case, your b becomes just, let me see, 11. C becomes 0. D becomes 0. And E is equal to 2. Very well. So our f of s is nothing but 2 divided by s minus 3 plus 11 over s minus 3 squared. These are 0 and plus 2 over s minus 3 to the fifth. Very well. So y of t becomes, let's see, 2 e to power 3t. And here you have to the second power, this guy becomes plus 11t e to power 3t. And since this guy has exponent 5, this is just 2 e to power 3t because of this translation that we had, 3t, and this becomes, well, here we have, need to have the factorial, you need to have 12 on the denominator, and here we get, so we can simplify that. Well, let's see. 4 times 2, because it was 4 factorial, and we get t to the 4th power. So eventually you can cancel these two out, and this is the solution for the differential equation that we were looking for.